Okay, so I don't know how many people are going to be watching live with the nice weather around, but here we have the last topic or last live stream for the quadratic relations and topics. Then the next step, which has been posted on EDSB. If you go on to EDSB now, you can find the lessons for the trigonometry. They are a little compressed just because there's a few things that need to be covered, and I wanted to try and get them in there. Normally I would have probably spread that out over probably a couple more lessons, but everything's there, and it will get reviewed as you need it in a grade 11 program as well. However, that's there, and then I'll start getting up the I got one more worksheet, the trigonometry checkup worksheet to put up there, and then I'll have the task that I know some of you are looking for. That'll be ready either tomorrow or Wednesday. So getting started with quadratic problems. I'm going to spend more time probably just taking up the setup for the problems than calculating each one, because most of them are just going to have us do a lot of the stuff that you've done already, and I don't want to spend all my time just calculating for you, but we'll get them all set up, and then you can refer back to the calculation methods as needed. And then if you have any additional questions, feel free to ask them to me. If you are joining us live, then you can send me messages via the chat, or you can send messages via EDSB or email, and I will get on. I will answer those throughout the chat. Otherwise, you can send me email or EDSB messages along the way, along the time when you need them, and I can help out. All right. So when we're looking at some of these problems, I will take a full look at question number 1 here with you. So if I switch over to the problems, in the case of number 1, we're looking to make a quadratic model for the height of a toy rocket launched upwards at 45 meters per second from a 2-meter platform, and then figuring out how long the rocket would take to fall to Earth rounded to the nearest hundredth of a second. So these questions here, these are questions that are actually going to be used if you take physics. So if you end up taking a physics class, you'll see these same types of questions, same types of formulas. Sometimes they'll approach some of the topics slightly different in a physics class, but there's a lot of this type of stuff that you will find in there as you move through your kinematics type of units. So this one here, what you want to do is, in general, the formula is the height at any time is given by negative 4.9 t squared plus the initial velocity, which we use v naught t, plus the initial height of the object. So we use that formula as our kind of guiding principles. The negative 4.9 again relates to the acceleration due to gravity. Most of the questions will be we work with are looking at gravity on Earth, so negative 4.9 is the value there, but that's half the acceleration due to gravity in general. So if we fill this in with the information that we were given, it was being launched at an initial velocity of 45 meters per second, and the initial height was from a 2-meter platform. So there's our equation that we can use. Right away, looking at this equation, I'm seeing some decimals in there and that. So when I move on to part B, which asks when does it fall to Earth? So the rocket's going to have something like this as a graph. It starts 2 meters up here, and so it's probably going to look something like this here. We want to find when it falls to Earth, so that's going to be one of the zeros or roots of the graph. There'll be 2 values. One should be negative, one should be positive, and we will pick the positive root in this case. So what we do is, knowing that that's a negative 4.9, the decimal there, I'm just going to go right to the quadratic formula, and when there's decimals involved, it makes everything easier. Instead of x, I'll use t equals, since we're replacing x with t in this case. So t equals the 45, so negative b, plus or minus the square root of b squared, 45 squared, minus 4 times the a value, negative 4.9, times the c value, 2. And all of that is over 2 times the a value. So I get this big formula here, and then I will just simplify that down until I get to the plus minus portion, and then I'll have to break it apart. So under the root there, I have 45 squared minus 4 times negative 4.9 times 2, and that gives me 2064.2. And then on the bottom there, I have negative 9.8. So now I can take that square root, and I'm going to get 45 approximately. Plus or minus the square root of 45.43-ish over negative 9.8. And then I will take the square, or sorry, that was the square root. And then when we work that out, we have to separate that into two components. Negative 45 plus 45.43 over negative 9.8, and then negative 45 minus 45.43 over negative 9.8. So we'll just work those out. Sorry, just my calculator's acting funny and I can't see the screen here, but there we go. Okay. So we have negative 0, 4, and then in the second case here, we have negative 45 minus 45.43 divided by negative 9.8. There we go. 9.2. 3. Sorry about that. Just took a moment. My calculator I think that it's getting very old. It's probably older than some of you kids are. So there's my two values. This is the one right here that I don't need, so this is the point of time that it will land on the ground. So all I'm doing is subbing those values, creating that formula using the general half the acceleration due to gravity, which, because we're using something near the Earth, we'll just use the negative 4.9 there, and then our initial velocity, our initial height. We sub those in to get the equation, and then we use that equation with the idea that we're looking for the zeros. So we set up the quadratic equation, filled in those values, simplified that, got down to my 2. This is the one I need, so negative 9.23 seconds is when that rocket's going to hit the ground. In the case of the next question, and again, most of these questions, if I'm not going to do the calculations for them because they're going to be the same kind of setup. But in the second one here, firework is launched upwards at a velocity of 49 meters per second with a height of 1.5 meters above the ground. So they already give you the formula in that case. What is the maximum height of the firework? So what you want to do there is the same thing that we did here. And now you're going to need to find the middle of these two. Recall that the vertex of a graph is directly in the middle of these two. The vertex of the parabola is going to be directly in the middle of these two. So we would add the two zeros that we get, and that will give us the x value. And then we can sub that in to find the y value. In the case of part B, what you would need to do to find when it's greater than 100 meters above the ground is sub that in for the h value. And sorry, my mouse is not transitioning well there. So what you would do in that part 2b is you would set h equal to 100 equals negative 4.9 t squared plus 49t plus 1.5. That would be your equation. You got to get it to 0, so we just move this 100 over by subtracting, and you'd have 0 equals negative 4.9 t squared plus 49t plus 1.5 minus 100. And then finally, the equation that you would factor is just going to have a different c value, and that c value is going to be 1.5 minus 100, or negative 98.5. So you just use that. That'll give you two zeros there once you put that into the quadratic formula, and those two zeros will be the values that the rocket is above 100 meters. In the case of the next question, which was number 3 here, number 3, the length of a rectangle is 16 centimeters greater than its width. The area is 35 meters. Find the dimensions of the rectangle to the nearest hundredth of a meter. It means we have to find the x's. So this is going to be set up similar to number 2. We're going to take our sides here. We have the length times the width equal to the area, which is 35. So there's the length times the width equals 35. I'll just expand that out. X squared plus 16x equals 35. And then move that 35 over. Minus 35 equals 0. There's my equation, and now I want to find the values that x can take, so we'll factor that out, and in this case here you can look for a simple trinomial factor. Are there two numbers that multiply to 35 and add to 16, or else you can use the quadratic formula. In this case, you're going to get a positive answer and a negative answer. In this case, because we're looking at the length of something, you can't use a negative x value as an answer, so you have to have you just use the positive number in that case. If they were both positive, then you could have two possibilities of where this situation would actually work. The next one I want to go over with you is number 4. Sorry, number 4, we're already there. So number 4, the product of two consecutive numbers is 3,306. What are the numbers? So in number 4, we have two consecutive numbers. So one number is x, the next number is going to be x plus 1. So x times x plus 1, because we're looking at the product of those two numbers, is 3,306. So this is the same setup as before. You would expand that out and do it. You could also do this, x minus 1 times x equals 3306. Both of these are two consecutive numbers. This and the one above it, this one and the one before it. So either case will work and get you the same answer. Generally, I like to use the plus 1. The next one is number 6 to take a look at. So in the case of number 6, the length of one leg of a right triangle is 7 centimeters more than the other leg. The length of the hypotenuse is 3 centimeters more than double the shorter leg. Find the lengths of the three sides. So while that text may be confusing, they've already set up the sides for you in the diagram that's provided. So in that diagram here, you already have those sides set up. And you can use the idea that you're finding the lengths of each of the three legs. So we need to relate these somehow. The only formula that we've worked with that relates the sides of a right triangle is the Pythagorean Theorem. So we use the Pythagorean Theorem, which is, a squared plus b squared equals the hypotenuse squared. And so we have x squared plus x plus 7 squared equals the hypotenuse, which is 2x plus 3 squared. And so then what you would do is you'd expand all these out, right? You'd get x squared plus 14x plus 49 equals 4x squared plus 12x plus 9. So you expand that all out. You'd simplify it down to a quadratic equation equal to 0. And then you can use factoring or the quadratic equation as necessary to solve that. This is number 6, not number 5. Number 6. And use the quadratic equation to solve that and find the value of x that could work. The next one I want to look at is number 11. And so in the case of number 11, we have a rectangle that has a perimeter of 23 and its area is 33. Determine the dimensions of the rectangle, including a diagram. So we have a perimeter, which is 2L plus 2W, and an area, which is L times W. And this one's easier to simplify, so I'm just going to fill in the values of A and P first. So what do we have? 23 is the perimeter. 23 is the perimeter. So 23 equals 2L plus 2W, and then 33 equals L times W. So I'm going to simplify or rearrange this one. Let's do W equals, so 33 over L equals W. So I'm going to take that and I'm going to sub it into this equation. So I'll have 23 equals 2L plus 2, and then the W is 33 over L. And then I'll expand this fraction, 2L plus 66 over L. Now, here's an issue. This has an L on the bottom of a fraction. It's kind of messing things up. I want to get rid of that L on the bottom of the fraction. And so to do that, I need to multiply this by L. But if I multiply this by L, I also have to multiply this by L. So I'm going to multiply this whole side by L. And if I do that, then that means I got to multiply this side by L as well. So I'm going to have 23L to keep everything the same and balanced, and then 2L squared, And these L's will cancel, and I'll get plus 66. Now I can just rearrange this. 0 equals 2L squared. I'm going to put this in the middle. Minus 23L plus 66. I got a quadratic equation. I can use whatever method works to solve that. And that'll find me my L's. That is number, what was that? Number 11. The next one I wanted to look at here, number 13. And so in the case of number 13, we're looking at 3 sides of a right triangle are consecutive integers. What is the length of each side? So this is a combination of ideas from a previous couple questions there that we did. 3 consecutive integers. 3 consecutive even integers. And so this one here, you got to be careful that it does say that we want even integers. So that means if your first number is x, the next even number would be x plus 2. And then the next even number after that would be x plus 4. So there's our 3 sides of our triangle. And then it is the it does say that it's a right triangle, so I know that the longest side has to be the x plus 4. So this side could be x plus 4, this could be x, and this could be x plus 2. Then I could sub those into the Pythagorean Theorem, expand, simplify that, and find my 3 values that would work. And I believe you're going to get 6, 8, 10 because it's based off the 3, 4, 5 triangle. The next one was number 15 and then 16. That will be the last 2 that we'll take a look at here. So number 15, if I switch over to there, number 15 says that a science experiment involves launching a small rocket. The following measures are taken. There's the initial height, there's the initial velocity. So we're going to create a quadratic model, similar to number 1. Verify the total time in the air and the maximum height, and then sketch the graph of this relation, labeling the key information as in example 1. So if you take a look at this, you'll use that same model. You'll put the initial height in for your h, and then your initial velocity. Then to verify the results, the total time in the air, that will be your 0. Again, you'll have one negative 0. That will be the positive 0. And then to find the maximum height, you'll need to find the middle of those zeros. And that'll give you the x value. And then you plug that into the initial equation, and that will give you the height at that time. And then sketching the graph, you can sketch that based on the example in number 1. In the case of question number 16, you're given the acceleration due to gravity on Earth is 9.8 meters per second. So again, you're going to end up with that 4.9 setup in the equation. A ball is thrown upwards at an initial velocity of 15 and with a height of 1. Round your answers to the nearest tenth of a centimeter. Write an equation for the height of the ball. So again, looking at that idea here, let's quickly write those equations for that one. So number 16, you're going to have your formula again is h equals negative 1/2 the gravity times t squared, the time squared, plus the initial velocity t plus the initial height. So in A, you would have h equals negative 4.9 t squared plus, what was it, 15 meters a second, so it's 15 t squared, plus an initial height of 1. Now, as we move down that question, the next part says, what's the height of the ball after 1 second? Sub 1 in for t. Simplify and you'll get h. What's the maximum height of the ball? Or sorry, after how many seconds does the ball land? Use the quadratic equation, find your zeros, use the positive one. D says what's the maximum height of the ball and when does this occur. Find your vertex by finding the middle of those two zeros to find the x value, which is when it occurs, and then sub that in to find the maximum height. Now, E and F have us do the same thing. However, something changes, and that's the gravity. So that's going to change your formula. So the formula for E is going to change lightly. It's going to be, again, it's 1/2 the gravity times t squared. So that's why we get the 4.9 on Earth. But in the case of the Moon, where the gravity is 1.62, half of that is going to be negative 0.81 t squared plus 15t plus 1. And then you'd go through the sequence of steps again, finding the zeros, finding the vertex. And then in the case of Jupiter, where the gravity is 23.1, again, we're going to just take half of that gravity. So that would be 11. What do we got? 11.5, 11.55. So 11.55. 11.55 t squared plus 15t plus 1. And again, you could do the same calculations on that as you did in the previous B, C, and D. So that is the setups for most of those questions. If you're having trouble actually calculating that along the way, most of them are just going to require to use the quadratic formula and get the zeros. And then in those couple cases where you have to find the vertex, then you can complete the square if you wish, or you can just find the middle of these zeros and sub in that value, which is the x value of the vertex, to get the y value. If you got any questions, again, feel free to send them on via Edsby, via email, and I can try and help you out with those. We'll see you guys next week.